Okay, number 4 has a ball being shot at an angle. We want to determine the initial speed, so the maximum height of the ball is 8 feet above its launch point. So let's start with our coordinate system. We'll launch it from the origin. So it's going to go something like that. We know the height right there is 8 feet. And we know the launch angle. Launch velocity is our unknown, and our launch angle is 30 degrees. Okay. So, we don't need to know, nothing is asked about time, so that would lead us to use the trajectory equation. But we're interested, or we know information about that point and that point. So we don't know anything about this x distance here. We don't know anything about time. So the trajectory, we don't know anything about the x distance or the velocity. So the trajectory equation will have two unknowns in it. So that leads us back to splitting this into two component directions. And obviously the y direction is what we know the most about, so let's look at that. Okay, we know initial and final y position, so our initial y position we've set as 0, and the final is 8. Okay, we know theta is 30 degrees. We want to find v0. If we find v0 in the y, okay, we will be able to know v's the total velocity. So that's a key. And we also know the final y velocity is 0 because we're at our maximum height. Okay, so I'll highlight that. Maximum height, that's a key point here. Means that. And we also know that the acceleration in y is minus 32.2. That's feet second squared. Alright, so if we use our y equations and look at these values here, again we'll come back to the theta, we have one that says y final minus y initial is equal to v final squared minus v initial squared, again in y times 2a. So we know everything about except our initial y velocity. That's what we want to find. And I'll put y's here too, just to remind ourselves that's just the y direction. Okay, so final y is 8, our initial y is 0. Okay, final y velocity is 0. Initial y velocity is what we're trying to find. Over 2 times minus 32.2. Okay. So if I solve for v0y, I can see that I have a negative sign on bottom, I have a negative sign on top, so those will cancel out. I'll basically just multiply out and take the square root. So let's do that here. So I'll have 8 times 2 times 32.2 and take the square root of that. 22.7. Okay. That's a real common mistake, is to use that as your final answer, but that's only one component of our velocity. So if we draw our velocity vector there, that's our y velocity, and we don't really care what the x velocity is, but we do know they're related by an angle of 30 degrees. So I can say that v0y is equal to v0 sine 30. Okay, I just solved for this. 22.7 is equal to v0 sine 30, and so v0 total is going to be that, which was our 40 45.4. Double check my calc there. Pretty sure it's right. 22.7 divided by sine 30. 45.4. Alright. And again, that's going to be units of feet per second.